Morning friends, in last we discussed about what is the wave and what is the wave front. What is the wave? Now the propagation of a disturbance in a medium, that is known as the wave. And last we will take the one example that as we of a small stone in a water, so circular ring are produced, that is known as the wave. Actually why the waves are circular form in water? Because this disturbance is propagated in all directions with the same speed. And due to that reason, this disturbance or this wave are shown in a circle. But if the wave are propagating in one medium at the time, so already we discussed in simple harmonic motion. So our figure is like this way. Already we discussed in last. That means due to the drop of the stone at that point here, this particle oscillate about their mean position, and the effect of this simple harmonic motion is propagated in one direction. Suppose there is the x direction. Therefore, the particle of the medium oscillate about their mean position this way. So this disturbance is propagated in this direction, that is known as a wave. Now, in water, this disturbance is propagated in one direction like this way. So, that is as a result, we obtain the one circle. As a result, we obtain the one circle. Okay. Now, what is the wave front? As the disturbance is propagated in all directions with the same speed. So, what are the points located at the equal distance from the origin? Are also oscillate in the same phase. That means the displacement of all these particles like this way at the same time remains same. Therefore, all the particles is either equilibrium position or maximum position or the lower position. Therefore, all the particles at a time are oscillate like this way. Therefore, the circular rings are obtained. Therefore, the imaginary surface of the imaginary curve passing to the points located at the same distance and oscillate with the same phase is known as the wave front. Again, the imaginary surface of the imaginary curve passing to the points are at equal distance from the origin and oscillate with the same amplitude or same phase. So this imaginary curve is known as the wave front. So last we discussed this definition of the wave and wave front. Today we are going to discuss about the different type of the wave front. Different types of the wave front. First is this type of the wave front. If the point source emitting the wave uniformly in all directions, suppose there is the point source continuously emitting or performing the simple harmonic motion like this way, inside, outside, inside, outside. So the effect of this simple harmonic motion is spread in all directions with the same speed. Therefore, the circular rings are generated from this origin and becomes the expanding, or its area becomes the more and more in all directions. Therefore, if a point source emitting waves uniformly in all directions, the point are at same distance, this point, are at same distance, right, from the source having the same amplitude and oscillate with the same phase. Therefore, the point are at same distance in all directions from the source, are oscillating with the same amplitude and same phase. So such curve or such sphere is known as the spherical wave front. That is known as the spherical wave front, that is shown in figure A. Now, who is the origin of a wave? Due to this oscillation of point O, here the circular rings are generated. Circular rings are generated, that means the spherical waves are produced. Now we consider the point lying in all directions are at same distance from the source. oscillating with the same amplitude and same phase. So this curve or this sphere is known as spherical wavefront. As the time passes, so spherical wavefront is going to expand. It means there is the propagating in the direction of propagation of a wave. That means there is the expanding. So that shows the direction of the propagation of a wave. Now the second. If we consider this small portion of this spherical wavefront at large distance, what's happened? This small portion of the spherical wavefront becomes the plane at infinite with a very large distance. So that is known as the plane wave or the plane wavefront. Again, the small portion of the spherical wavefront at large distance becomes a plane. So, which is known as the plane wavefront that is shown in figure. So here there is the waves at infinite distance are parallel to each other as we consider the cross section at any point. So here all the points lying on this plane oscillate with the same amplitude and same phase. Therefore, that is known as the plane wavefront. That is known as the plane wavefront. There is the spherical wavefront. There is spherical wavefront. Okay. Now for the spherical and plane wavefront, the source is a point source. The source is point source. Actually, the plane wavefront is also a spherical wavefront, but here there is a very close distance from the source, and there is a very large distance from the source. The spherical wavefront at large distance becomes the plane wavefront, or the behaves as a plane wave. Now, third portion is that there is the cylindrical wavefront. The cylindrical wavefront. The wave originating from a linear source and propagating in three-dimensional homogeneous isotopic medium. Homogeneous isotopic medium is known as the cylindrical wavefront. Instead of the point source, instead of a point source, if the source is lying on the linear, if the source is lying on the linear like this way, this line is oscillate in a medium. So what's happened? The disturbance produced in a medium is also a linear disturbance. If this disturbance is propagated in three dimensions, so here the cylindrical wave and cylindrical wavefront are generated. Wavefronts are generated. Now the example of the spherical and plane wavefront is that what are the light rays or the light coming to the bulb, electric bulb. So these are the example of the spherical wavefront at close distance from the bulb. But at infinite distance, so what are the light coming from the bulb behave as a plane wavefront. Behave as a plane wavefront. Now, what is the light coming from the tube light? What is the light coming from the tube light? So this light in three dimensions behaves cylindrical wave or the cylindrical wavefront, because the points on any one wave are same distance from the source, and these points all these points of this wave oscillate with the same phase and with same amplitude. Therefore, this now Huygens principle. Now the question sometimes the 2 marks ask like that way. Write and explain the Huygens principle or explain the use of wavefront to understand the wave propagation. For that purpose, you have first the principle or the Huygens principle. Every point of the particles of a wavefront behave as a secondary source and emit the secondary spherical wave. Again, every point of the particle, every point for the particle of a wavefront behave as a secondary source and emits the secondary spherical waves itself. After a small time interval, the surface tangential to all secondary spherical wave gives the position and shape of a new wave front. Again, the surface tangential to all secondary spherical wave gives the position and shape of a new wave front. So keep in mind the statement. Again, the evaporates of the particle of a wave front behave as a independent secondary source and emits the spherical secondary waves itself. After a small time interval, the surface tangential to all spherical secondary waves gives the position and shape of a new wave front. There is the Huygens principle. In short, according to the Huygens principle, all the points on a wave front also behave as a secondary source and itself emitting the secondary wave. Actually, what's happened? Due to we dropped a stone in a water, suppose here the stone is dropped. So the disturbance is propagated in all direction. When this disturbance is passing to the different point of medium through which it propagates. So when this disturbance is passing on this point will also be a source of a wave and emit the wave in all direction. Emit the waves in all direction. Therefore, the waves are generated in one direction like this way, from this point. Now, let's review the tangent to this secondary spherical wave that gives the new shape and position of a wave front. So, that is the statement of the Huygens principle. Now, let's solve the figure. Let's solve the figure F1, F2 represents a spherical wave front. This F1, F2 represents a spherical wave front. Now, all the points of the particle, like as the A, B, C, act as a secondary source and produce the secondary spherical wave itself. Here we consider the point A, B, C. These points act as a spherical secondary source and emits the spherical secondary waves. Now, if the velocity of a wave in given medium is v, therefore, in t time, the distance traveled by the secondary waves produced by the point A, B, C. Distance traveled in all direction is v into tau. This side also v into tau. That will also v into tau. V into tau. Right? The distance traveled in t time is v into tau. Therefore, to determine the shape of a new wave front, at time t is equal to tau. F1, F2 is time t is equal to 0, while the G1, G2 and t is equal to tau time. What is the wave front at t is equal to tau time? For that purpose, we do a sphere from the point A, B, C, having the radius is equal to v from its point. So that is the spherical wave front. And draw a common tangent to this sphere. We draw a common tangent to this sphere. So this tangential surface gives the position and shape of a new wave front at time t is equal to tau. Again, according to our Huygens principle, here we consider the F1, F2 is a spherical wave front. According to our principle, all the points of the particle of this wave front behave as the secondary source and emit the secondary spherical wave itself. Now, if the velocity of a wave in given medium is v, therefore in tau time, the distance traveled by the wave produced from A, B, C point are v into tau in all directions. V into tau in all directions. Therefore, at time t is equal to tau, what is the new shape of a wavefront? To determine the shape and position of a new wavefront, we had to do a sphere from point A, B, C with radius V. With radius V, therefore this sphere, and at point C, this sphere is obtained. Now, the tangential, common tangential to this, all this sphere, or all this secondary spherical wave, that this tangential G1, G2 gives the new shape and size or the position of a new wavefront at time t is equal to tau. The similar way, D1, D2 is also the tangential surface to this secondary sphere, this secondary spherical wave. Therefore, that also gives the position and shape of new wavefront at time t is equal to tau. Here, G1, G2, there is a wavefront in forward direction, and D1, D2 is also a spherical wavefront in back direction. All this wavefront has the point source are the point of a spherical wavefront at forward angle. So this is the explanation of the Huygens principle. Here the Huygens principle is very important because frequently we are using this chapter, and explanation in spherical wavefront is this. Now, what is the explanation of Huygens principle for the plane wavefront? We discuss after this. Now, just we discuss the Huygens principle for the spherical wave. Now, how we explain the Huygens principle for the plane wavefront? So, for that purpose here, in figure, the plane wavefront F1, F2 is shown. Now, F1, F2 is the plane wavefront at time t is equal to 0. T is equal to 0. According to the Huygens principle, all the points of this plane wavefront act as an independent secondary source and produce the secondary spherical wave itself. So here I consider the 3 points on this plane wavefront. These are the A, B, and C. If the velocity of the wave, secondary wave produced from this point A, B, C is V, therefore after t time, the distance travelled by secondary waves are equal in all direction. And due to that result, I drew a circle of radius V into tau. V into tau from point C. From point A, B, and C. That means by considering this point A, B, C as the center, and we do the sphere of radius V into tau. And the tangential surface to all these secondary spherical wave gives the position and shape of new wavefront at time tau. At time tau. In figure, G1, G2 is the new wavefront at t is equal to tau in forward direction, while D1, D2 is the another wavefront in back direction also at the same time. Also at the same time. Again, how we explain the plane wavefront, or how we explain the Huygens principle for plane wavefront. So as shown in the figure, the F1, F2 is the plane wavefront at time t is equal to 0, which is propagating in right direction. Actually in all direction, but here we consider this wave is propagating in right direction. Now, if the velocity of a wave is v in given medium, therefore in tau time, so what are the waves produced from A, B, C? Because according to the Huygens principle, all the points on plane wavefront like as the A, B, C, and etc. act as a secondary source and produce the secondary spherical wave itself. This wave travel distance in tau time is v into tau. Therefore, I do the circle by taking the point A, B, C as the center. So, circle of radius v into tau. Of radius v into tau. According to the Huygens principle, the points A, B, C of wavefront F1, F2 act as independent secondary source and emits the secondary spherical waves of radius v into tau. After time interval tau, the surface tangential to all these secondary waves gives the position and shape of the new wavefront. So there is the Huygens principle. Here G1, G2 is the new wavefront in forward direction, while the D1, D2 is the new wavefront in back direction at time t is equal to tau. Now listen, here A, A1, B, B1, C, C1 are perpendicular to the wavefront F1, F2 and G1, G2, which is known as the light ray. There is known as the light ray. Thus, the Huygens principle or the Huygens wave theory can be applied to all type of the wavefront, like as the spherical and also the plane wavefront. Again, the Huygens wave theory can be applied to all these type of the wavefront, like as the spherical and also the plane wavefront. So there is the Huygens principle for a plane wavefront. The principle is same for all the points of a wavefront behave as the secondary source and emits the secondary spherical wave itself. After the some interval time, the surface tangential to all secondary spherical wave gives the same end position of a new wavefront. Clear this? So there is the Huygens principle. Clear? Okay. Just we discussed about the Huygens principle for spherical wavefront and plane wavefront. In both, we discussed about that the each and every particle of a wavefront behave as a secondary source and independent secondary source and emits the secondary spherical waves itself. Right? That means we consider the one wavefront, so in forward direction and back direction, both sides. After a small interval of time, we obtain the wavefront. We obtain the wavefront. But actually, what's happened? So here the limitation of the Huygens principle is that only we obtain the wavefront in forward direction. That means in the direction of propagation of the wave, not in back direction. So now the amplitude of such secondary wavelets is maximum in forward direction but zero in back direction. So in other words, we not obtain the secondary spherical waves in back direction, not in back direction. Therefore, the Huygens cannot explain this thing. Why the amplitude of the secondary wavefront in forward direction is maximum, but the zero in back direction. The other scientists like S, Webb and Kirchhoff, after the number of the experiment, they proved that the such limitation and state that the intensity of the secondary wave proportional to the one term, this term is 1 plus cos square theta by v. Again, the Huygens cannot explain why the wave not propagate in back direction, only propagate in forward direction. So the other scientists, Webb and Kirchhoff, explain such limitation and state that the intensity of the secondary wave proportional to the term 1 plus cos square theta by 2, where the theta is the angle made by the wavefront in the direction of propagation. Now in forward direction, theta is equal to 0. Therefore, theta by 2 is 0, cos square 0, cos 0 1, therefore 1 square. Therefore 1 plus 1, the intensity of the new wavefront in forward direction is double. 1 plus 1 is equal to 2. Now what's happening in back direction? So here, the direction of propagation is suppose in x direction, while the wavefront obtained in back direction, that means in negative x direction, is therefore the angle between the forward direction and back direction is theta is equal to pi. Hence the intensity is 1 plus cos 2 theta by 2. Cos theta by 2, that means theta is equal to pi. Cos pi minus 1. Therefore 1 minus 1 is equal to 0. Thus the intensity of the light in back direction is 0. Therefore, according to the Huygens principle, each and every points of the particles of the wavefront act as independent secondary source and produce the secondary spherical waves itself. But here, this newly produced the secondary spherical waves also propagate in the direction of propagation of the wave, not in back direction. So there is the limitation of Huygens principle, and this limitation cannot be explained by the Huygens, and that is explained by the Kirchhoff and Boyle. Clear this? Because the intensity of the wave depends on the term 1 plus cos square theta by 2. By considering the angle theta is equal to 0 for forward direction and theta is equal to pi in back direction, we can get intensity of the wavefront in forward direction is maximum, while in back direction is